Thank you, and yeah, great to connect with everybody. It's yeah, very strange times. I've been doing the Hoop Summit for a new number of years. Obviously they're usually closer to where you live. I guess one part that people are kind of enjoying about this Zoom world is you get a little window into people's home life. So I'm sitting here in my living room, which is generally where I'm working these days. I have my three kids running around, so hopefully they've been warned. Hopefully they won't kind of come in and interrupt me. But yeah, I'm happy to be here and kind of talking to you and connecting with you and kind of just giving some insights into our vision around the digital factory. As Jonathan mentioned, we've tried to take these Hoop Summits and kind of think of them in a virtual context. And we took a little bit of a change in direction, and we tried to do kind of three different classes of presentations, and they've been occurring over a 4-week period. And we're right in the middle of it now. At the lowest level, there's essentially a set of training sessions which are hosted by our consulting engineers, and they're really about writing code, introducing people how to use our APIs. We've done two already. We have another two coming up in the following 2 weeks, and they've been on Tuesdays. On Wednesdays, we've been doing some sessions, and the initial ones were focused on getting roadmaps. And so you had Eric and Lionel talking about Hoops Exchange, Hoops Communicator, Hoops Visualize, Hoops Publish, some of the logic behind what we're putting into the product today, and talking a little more longer term about things. What we're talking about, then me and Jonathan are doing these more industry focused ones. And we decided to focus on the digital factory. Today, I'm going to talk about what's involved in building the digital factory. And Jonathan's going to kind of continue the conversation next week at the same time, talking about manufacturing in the context of the digital factory. These are meant to be topical introductions to the digital factory. We are very familiar with these spaces. We've got more educated in them as we have our partners coming in and building solutions for the digital factory. And I kind of wanted to talk about, one thing that's pretty exciting about this digital factory and generally what we do. I'm very proud. As I get older, I get a little more nostalgic about what I do. But, we're excited about engineering software and the impact that has on the world. And I think it's really important to realize that a lot of the important problems we need to solve are being done in the engineering world, and we play a small part in that. And I think the digital factory is one of the areas that really excites us as kind of the next step and really where our industry can be impactful in the world. So before I kind of get into the digital factory, I think it's really important to kind of think of how engineering software has evolved and addressed issues in the manufacturing and the construction markets as building blocks into talking about the digital factory. And I think as we start talking about that, you really got to look at the digital assets, the digital model within manufacturing. So let's start at manufacturing. And if you kind of think over time, initially why people adopted engineering software particularly the manufacturing space was initially it was about design, but very quickly it went into the analysis space. And CAD and manufacturing in particular is probably a 50-year-old industry. It was one of the very first industries to adopt engineering or adopt software. And really what you've seen over those 50 years is a slow transition to more and more software being used as something goes from being designed to being manufactured and then to actually living out in the real world. And so if we kind of look at that transition, you can see, initially you had a mathematical description in the model that was available for analysis. As we got into manufacturing, the product manufacturing information was very important for putting in there. GD&T is what it was initially called, product manufacturing information is what it's called today. And that information going into the model enabled industries like CAM, which is a massive market for engineering software. CMM, where we're measuring the software. Because we have the tolerances, we're able to take in the 3D model and have hardware verifying that the manufactured part is within the defined tolerances. So you kind of see this information going into model. The next phase was the constraints information, how parts in the assemblies connect and mate to each other. That ultimately impacts how an object can move. And that's very important as you look into automation and you kind of getting into the digital factory and how robots can operate within a factory. The most recent thing that we're starting to see now in the manufacturing space is the information for attaching IoT to those devices. So that's now we're moving out of the manufacturing phase and into the actual that object living post-production. And so that's where you're talking about the digital twin. And the digital twin is really important if you're talking to manufacturers about having kind of product as a service so they can do predictive maintenance. So you kind of see this evolution over the last 50 years and the amount of opportunity that's been created by that. When we initially started in CAD, it was really about design. Little did people have a vision that down the road there would be 20 times more revenue and cost savings found through software that was outside of design. And if you look at our customer base today, we have huge parts of it that are in the CAM space or the CMM space or the metrology space that didn't exist or were negligible 20 years ago. If we look at that same trend in the construction space, it was the same idea. Initially, in the construction space, they really looked to engineering software to help facilitate design. It's a little different in the construction space, where in the manufacturing space, you're generally pushing more and more towards automation, and you have more and more less and less people involved in the creation of something, and so there was a lot more software involved in the manufacturing side. When you move over to construction, it's a little different, and it's really where a lot of the savings is that by and large you have people on construction sites building buildings, and so where a lot of the opportunity that was seen in the construction space was around quantity takeoff applications, scheduling software, and there was huge cost savings that were enabled by having a digital model, which required a further investment in the amount of information that they put into their digital model. And we're going to have Luli Lee talk a little about what Fieldwire do, and she'll kind of show you an application that is exactly designed at that and reducing costs by leveraging the digital assets. So I think as we kind of look at those two markets and the evolution of them and the opportunity that's being created in those markets by an investment in the digital model, we believe the digital factory is the next frontier on that front, and that there is massive opportunity for our community within this digital factory. And so I want to start off by defining what the digital factory is, and then I'm going to kind of talk about a couple of the challenges in this space, some of which are problems that we're trying to solve, and some of them is ultimately up for our industry to solve. But what the digital factory really about is, first of all, we have these digital assets, and your building is designed in Revit, and these industrial machines that live within the factory are designed in typically an industrial design application like SolidWorks or NX or CATIA, and it's about bringing those things together. Then it's about connecting IoT devices can bring those things alive, and then you have that data augmented with other information. Some of it can be 3D scanning information, some of it can be inventory information, and it's about all this digital information coming together to create an intelligent factory. And so this, as data moves into the digital domain, it opens that data up to the power of algorithms, the scalability of computing. And that's where we can start, that's where the real opportunity starts arising. So as this domain gets fully digitized, there's massive opportunity being created. And certainly if you look at what's happening today, and as if you're a manufacturer today and this worldwide pandemic, certainly your investments in the digital factory, which is connected to automation, is, this is going to be an area that they're going to even more invest in. So I'm going to talk about some of the challenges of creating solutions for the digital factory. But before doing that, I wanted to talk about a partner who we're actually already working on in this area. And our partnership with them has helped educate us a lot on some of the problems that need to be solved here. So Samsung SDS, or the services department for Samsung, they are a multi-billion-dollar a year company, and they provide software solutions into Samsung and other companies. And as you can imagine, as Samsung being one of the leading manufacturers in the world, they have a huge interest in the digital factory and the savings that that can bring to them. And so they've created something called the Next Plant 3DX platform, and that's really the platform for building their digital factory solutions. They talked at our Hoop Summit last year. This is a slide that was in that presentation and that they allowed me to share today. And I wanted to highlight two areas that I found have been most interesting for us to work on. The first is in this design review stage. So when you look at Samsung, they're bringing in Revit data, and their industrial machines, some of them they have the CAD for, some of them they actually have designed in their own custom systems. So they needed to be able to have a system which could take this heterogeneous data, some of which came from files and some of which they authored themselves. So we had a system which allowed them to do that. And there were some real challenges around scaling to these systems. If you look at these fabrication plants that they have for some of these chips, there are tens of thousands of these complicated industrial machines that live in these fabrication plants. And so the scalability of dealing with this issue was really, really challenging. So we had to bring in the Revit data, bring in these industrial machines, handle the scalability, and allow them to then work and view this data remotely, either on a mobile device, through a browser. And so being able to solve these challenges has been a fun problem to work on. And I think that's the basis of a lot of digital factory solutions. Almost all of them involve some macro view of the factory operating that you can view remotely. So that was being a fun project to work on. The other part that's really interesting is augmented reality. And obviously, Samsung have a vested interest as one of the leading manufacturers of mobile devices. Augmented reality is something that they truly believe in. But in their world, they really do see it being a powerful tool in the digital factory. And so suddenly they see a lot of their service repair use cases being serviced by augmented reality. And so it's been interesting to work with them and be able to have a device that they go on site, they're able to scan in a QR code and automatically load that digital model. And there's some, I'll talk about them in a little more, but there are some real challenges around how you can solve alignment issues and have a digital asset be put into the physical world and have it line up correctly. So they've been two of the kind of interesting parts of working on that project, and it's, as I say, a really exciting project to be working for us as a company, and certainly has fueled a lot of our insights and excitement around this area. So I'm going to just highlight, this is a topical discussion, and so I'm going to just highlight two of the main areas that we see as where the difficult problems are when we talk about the digital factory. And the first one is just creating your digital factory. Just creating a 3D model that brings together construction data and manufacturing data comes with its challenges. And the great thing is that because of these investments that the construction and manufacturing world have been making, they have solved a lot of the problems of, they have 3D representations of their models. They have every part modeled down to an individual case. You can't do a quantity takeoff application if you don't have every door and every window modeled. You can't build a digital twin if you don't have your industrial machines with having the ability to connect to IoT sensors. So being able to bring this data already to work that both the construction and the manufacturing world have done in investing in our 3D models enables this to happen. But still, you do have these disparate worlds. So the manufacturing and the construction worlds, they tend to just be independent worlds. And so while there's a lot of similarities in the data, bringing those two things together presents some of its challenges. And that's why in the last 2 to 3 years, historically, we've always had a strong set of technology around bringing in manufacturing data. On the construction side, our support was a little weaker. We identified that, and 2 to 3 years ago, we brought in Revit and start bringing in more of this construction data. And when you talk about construction data, 2D continues to be a very important format. So from a data access side, we now allow people to bring both of these types of data in. Then what the problem quickly becomes is the scalability side of things. So if you're talking about some of these industrial machines that you're seeing on this right side, they're probably 10, 15,000 components. I know in Jonathan's demo, he'll show you some of these industrial machines. They're going to have tens of thousands of these machines, certainly when you talk about some of these fab plants. So you really start the scalability of these issues. Similarly, if you're talking about the construction model, if it's modeled down to a detail level, again, you're talking about tens of thousands of objects. So this is where you start running into scalability issues. And for those who were part of the product managers presentations last week, you'll hear them talking about having our client server architecture visualization engine, which drives our mobile viewing or our web-based viewing connected to other viewing solutions. So we can enable client server viewing of data independent of whether the technology used from us, from your own custom built solution, but really allowing this client server viewing technology to work with a broad variety of different viewing clients. So that's the first problem. We feel we've solved a lot of the problems on the merging of the data, and the issue that we're focused on today that we've made fantastic strides on, but believe there's still work to be done, is on that scalability side of things. The second thing I wanted to kind of just talk about, and I was trying to think of how I would describe these series of challenges, and the best I could do was kind of just talk about this idea of getting from a dream to reality with these new technologies. And what I mean by that is, let's take, for example, IoT. This concept of having sensors on devices and wirelessly transmitting back information in a secure way to a centralized location is incredible. And the truth is, that's the reality today. That does happen. And so you have the digital twin that exists today and has been in use in the industry today. The challenge there that involves is connecting the IoT device back to the digital asset. Sometimes that's easy when it's simply a location, and that might be the case for temperature sensors or these kind of sensors that are in a digital factory. When you get to a specific sensor that's attached to a particular device that maybe has movement attached to it, that can be a little complicated, and that requires you to connect into the engineering model at a low level. And the nice thing about when you work with engineering data is that you have that granularity where you can make that connection. And so from an IoT perspective, actually bringing the factory to life is not a difficult thing to do. If you have the digital factory, it's fairly easy to connect IoT data to your devices, and we work with many partners that do that today. TechSoft is a platform provider is always trying to look at places where we have multiple partners solving the same problem, and we try and solve that for them. IoT would be one of those that fits in that classic area. The challenge today is there's not really a standard around IoT, and so generally what we do is we do custom connections there, but generally it's not a challenging thing. The next technology, when people talk about the digital factory and technology that can really be impactful, they talk about augmented reality. And this is where one of those ones, I think that's more in a dream area than it is the reality. If you look at augmented reality, people, you can take, I think the biggest app that came out was when you could put, go around capturing Pokemons around your neighborhood. And the truth is, it's actually pretty good at that. The augmented reality, if you look at AR Core or AR Kit, they allow you to place a digital asset into an environment. It provides information on the environment so that you can make that thing have the look and feel of that environment, so the lighting and shadowing is done correct. But that's really where it stops. If you think of what we need in the engineering world, we have our building, we already have that designed. We want to walk into that physical world and have that aligned with the digital world, aligned with the physical world. Well, that alignment issue is a real challenge and not solved today. You'll see people like PTC, they acquired a Vuforia technology, which was moving down that space. We believe that Google and Apple, they've identified AR as hugely impactful technologies for the growth of their mobile platforms. We believe they're going to solve it. But that's where AR is not really going to have the impact on this industry, on our specific industry, until that problem is solved. Similarly, there's other technologies when it comes to, for example, 3D scanning and having that technology coming in and overlaid perfectly with your data. There's some problems to be solved there. And then thinking more broadly of just this idea of a digital factory. And suddenly you have massive amounts of data that are coming into the system, and how you process that and start doing smart things with it. So you can start doing predictive maintenance. And this is where you start coming into technologies like machine learning can start being impactful. But that's where I think the opportunities for us arise, is solving some of these big problems. And we see ourselves solving some of those, but really we see a lot of them being solved by our community, and that's where the real opportunity resides. So that's just kind of a topical discussion of two of the challenges around the digital factory. I'm going to hand things over to Jonathan now, and he'll kind of show some demonstrations of this technology in action.
Oh, great. Thanks, Gavin. So let's take a look at this and how we're enabling these types of workflows using our technology. Like Hoops Exchange here has brought in some CAD data from a Revit file. We're able to visualize it now in a thin web viewer using Hoops Communicator. All the views that were originally in that Revit file can be kind of enabled here. You can create custom views using Hoops Communicator. But what we want to showcase is not just our ability to bring in CAD data, but link it with other types of other frameworks or databases. So this is showing you how to slice and dice data. All of the data has been pre-processed using a BIM connector engine from Sauna.io, one of our partners and a component provider as well. So I can kind of view this by floor. We just saw the second floor, or by category, which is a paradigm here in construction data. I can turn off everything and here, like turn on, let's say, walls, the curtain panels, and structural columns. So depending on how my data is organized, I can now change the 3D view. We're going to go back to our floor view, and another way we can overlay additional data is through, let's say, a construction timeline. So here, starting from day 0, I can kind of go to different snapshots of how this is going to be built over time, and again, enact or show what's happening in 3D and what I should expect at those particular milestones. Another very challenging problem that Sauna has has solved or is working on is connecting 3D data with 2D data. So here we have really a federated model. We've been able to read in the DWG data for the floors as well as a 2D plan, and Gavin was talking about that, and connect it together. And Sana has gone through and organized this data and created a data backend that allows me to do things like link together selection of a wall in 3D and the wall in 2D, or this shade support in 2D, and be able to display it here in 3D. And that's not an easy problem to solve. So being able to show this is really exciting. There's also a federated search. So bringing all of this data together and additional data, we can now search for things like, let's say, walls. And we have different suggestions as well. We're searching in the category section, but we can show, let's say, all the walls on the first floor. And that gives us a list that we can now step through and again, be able to display it not just in 3D, but in 2D, and have it zoom exactly to that location, and be able to display it up here in the model browser as well as we walk through each of those elements. And so now we're overlaying a data model on top of your 3D and your 2D data. We can do some very interesting things like search, in this case, for doors, but maybe I'm not interested in the categories, but this data can be also organized by, let's say, family. What's really interesting here is there's no door text in the object name, but the Sana BIM connector has allowed us to actually classify objects in this family and notice that they're doors and have this intelligent search mechanism. And again, we can kind of change the way in which our 3D data is being displayed with these filters. And that's Hoops Communicator being able to do that in a graphical way, and Hoops Exchange being able to provide all of this data for visualization. So here's some real just classic building and construction, being able to walk you through different views of your data and bring it all together. It's all being skinned in a custom UI. That's something too that is up to you. We don't really enforce you using any specific UI. What we just do is provide you with all the data and this 3D and 2D rendering. We can do other things like look at priority, or look at the owner of particular objects, look at different Gantt charts, or like what's been completed as part of this project at a particular time point, or who owns all of a particular set of objects, and be able to filter that way. So just a lot of different views into your 3D data, giving you more than just a dumb model, but being able to navigate it in all these different ways. The next thing we want to show is now maybe Gavin, you can move on to the next one. You mentioned bringing a factory to life, and so here's a demo looking at a dashboard for a fictitious digital factory, bringing in IoT data, consumption, energy consumption, as well as like environmental information about humidity in the factory and temperature. But what we really want to do is bring this to life using 3D data. So let's take a look at our actual factory, and we're bringing together both construction data and mechanical information. In this case, it's a digital factory, so we have an assembly line with ProEngineer cars and 3D printers and CNC machines, but it could also just be mechanical data coming from HVAC plans. And so what we're trying to do is create this very complicated federated model and be able to visualize it very, very quickly. So it's a relatively large model. We have a list of all of our couple hundred different robots and different tools and machines in this space, and we can actually kind of go to that in our list and zoom into the 3D factory where that's located. And in fact, we've also added to that animation. So this is something we're working on in all of our visualization products, is adding animation. We can step through each of these different machines and kind of walk down the line, or we can blow it up and look at our full 3D view, because that's what we might be interested in. But again, we want to bring this to life, and so we want to overlay additional information coming through. Like, let's say we want to showcase all the problematic machines, and so which of these have a significant amount of downtime or have fault errors, and can I see that in 3D? So that the next thing you'll see here is our ability to show problem machines, and they're all highlighted here in our 3D view. and soon populating, you'll see little icons or charts above each of those machines showing exactly for that machine at a very quick glance what's going on with that machine, and I can troubleshoot that and procure maintenance records or load that 3D model and try to troubleshoot it as well. So let's exit our 3D view and look at a few other things here as well. So we're going to go down our list of machines and bring up a CNC machine. And you'll notice again, we zoom in our 3D view, but we also here in our preview, we bring in the entire 3D model. And so we've done a number of performance tuning to load low fidelity models in the main factory and high fidelity models here in the preview, and be able to push them back and forth as well. So if I want to troubleshoot in the main 3D model, I can do that by loading the entire model. But because we have the whole mechanical assembly, we have a bill of materials or a filtered bill of materials up here on the right. And each of the units that, let's say, may be attached to some IoT sensor providing information, we can present that in our preview view. Let's say this drill or the motor, we can now bring in additional information from, let's say, the number of faults or when it was last replaced, and further kind of drill down into this data-rich model, both 3D and IoT data or data from a database. Another thing we might want to do is walk through different messages that say technicians have annotated. So here we're looking at a machine. We need to find a different supplier for this part. We're going to load the full machine to kind of get our full context. And again, this is modeled down to the panel, individual panel or individual bolt with high fidelity information. So we're able to kind of switch between fast animation and walking through this factory to really drilling down and getting these rich 3D models. Here, another one, we have a 3D printer. And in this case, maybe we need to replace this fan. Is it too loud? And we can kind of display additional information there as well. But this is a dynamic environment. It's a dashboard. And so if I wanted to, I was in our California factory, but I could also, let's say, swap to our French factory. And again, here we just loaded dynamically our building and what's in the building. So we have the walls, staircases, lights, overhead doors. But here we have a number of different pieces of machinery. It looks like an army of 3D printers, but then also we have a significantly detailed model that we can load in here as well. This has over 40,000 parts and hundreds of thousands of triangles. And I remember when we first were kind of working with this data, just loading this one machine was really impressive. Now we can load multiple copies of this machine and be able to visualize it. The same thing is I can swap back and forth between Lyon, the French office, and the French, we have our French site and our California site. So just a lot of different stuff going on there, being able to navigate your 3D data and augment it with real-time data from anywhere, IoT sensors or databases or bill of materials. So really creating just these rich 3D environments. And so the last thing we want to show, Gavin was talking about it, is we've been looking at the web, but what are we doing for desktop and mobile? And so using Hoops Visualize, which is our graphics engine for desktop and mobile, we're going to show kind of the combination of a streaming database of 3D assets and being able to show that in a native application. So this is a C++ application running on a desktop. We need to connect to a server. I'm going to connect to a server running locally on my machine, but this could be off on the Azure or AWS cloud. And I want to load a large model. And we're not loading this from a file, but it's kind of like a streaming set of files. We're going to load a Boeing 777, so it's a 30 gigabyte CATIA data set. We're also going to clamp the memory because on, let's say, mobile devices, we don't have all of the graphical resources we might have on a desktop machine. And now we're gonna pull in some metadata and we're gonna start the server. It's gonna start streaming in data. So this is like our back-end web server streaming data to a local client. And we're gonna clamp it to use a certain amount of resources. So what you're gonna start to see are these blue bounding boxes, and that's where we're gonna start loading data in. And once we hit that limit, and it could be limitless, but once we hit that limit, we're gonna stop streaming data in and allow you to kind of see these large objects. And so once those boxes go away, we've kind of reached the stable state. But the next thing we may want to do is, let's say, drill down into some more detailed data. So we're gonna, let's say, rotate this Boeing and look at the turbine engine and zoom in and see what's, so try to load in specific detail for this region, offloading other data. So we're able to load this in dynamically, offload other data, and still be able to maintain that memory cap. As we zoom back out, that detailed information will be offloaded. You'll see some red boxes, bounding boxes, where we're going to be filling data in. So this project, as well as some of our other projects, you can kind of kick the tires on it yourself by going to labs.techsoft3d.com and kind of see this as well, be able to download some of the projects and be able to use them. And this is kind of coming up in some of our future releases of Hoops Visualize. We're really excited to be able to have this scaling technology across all of our products. So those are the demos. I want to hand it back to Gavin. He's going to talk about some opportunities in this space for developing applications and working together.
Thank you, Jonathan. I'm always impressed that you can talk that through so well. Thank you for that. So I'm going to just quickly wrap things up and then hand things over to Luli, and she can talk through her presentation, which has got some really interesting stuff in there. Hopefully, you know, the discussion that we've talked today has kind of piqued some interest. If you're an existing partner of ours that doesn't necessarily work in the digital factory, hopefully you've heard enough today to kind of pique your interest and maybe think about, you know, what you could maybe do. There's certainly a lot of interesting problems to solve in this space, or maybe just adapt your technology to make it more useful in the digital factory. If you are a partner in this digital factory space, you know, we really appreciate the collaboration we've been having with you. Hopefully you're seeing the investments that we're putting into this area, and hopefully you know, we'd like to communicate about it. And while we feel we're in the right direction, we're certainly always open to listening to what you say and iterating and moving to meet your needs. And finally, if you are just a new developer and just kind of trying to understand this engineering software world, Jonathan talked a little bit about at the start. It's very easy to get access to our tools. We have some targeted at web developers, some targeted at C++ developers, and we'd be more than happy to kind of get those tools in your hands and let you start seeing how easy it is to start building solutions for the engineering software market. So I'll open it quickly for Q&As, but I don't want to. We will have another opportunity at the end to come back to Q&As after Luli wraps up. So,
yeah, Gavin, one question came in, and please feel free to populate the chat with any other questions you may have. We'll answer them now or later. Do you support point clouds?
Yes, so we do support point clouds. When we generally talk about supporting a format, there's kind of two parts to it. The first is being able to read the data. And point clouds, fortunately, are very simple. They're generally a location, and they occasionally have a color with them. We do support a couple of formats, including PTS, PTX. We have some of the Leica formats. The second part to it, which is actually where the problem lives, is supporting the size of these models. So some of these point clouds are hundreds of millions of individual points. And you can't support them without having what we call out of core, which means that you don't load the whole model in, but you start making decisions about the objects that are relevant based on your spatial location. And we support that in our client server technology that actually Jonathan was just showing just a second ago. That same idea of setting a memory limit and then only loading in, let's say, 1 million points, but making sure they're the most important 1 million points. The second part to it is, you know, when you come to point clouds, it's a point, right? So it's an infinitely small object. Generally, when you want to look at point clouds, as you get closer to objects, you want to have some kind of volumetric element to them, and there's a widely used technique called splat rendering, which we support. So yes, so point clouds we do support, and we kind of think that's important in this digital factory where, you know, you might have the digital assets representing the as designed object, and then the scanning comes in to kind of actually show what it's like in the real world.
Great. Thanks, Gavin. Any other questions? You can type them in the chat. We'll have an opportunity to answer them at the end, but maybe we can swap presenters now. And we'd like to introduce Luli Lee, product manager at Fieldwire. We're really excited to have you here. Thank you so much, Luli, for participating. And we're eager to hear what you have to tell us about what you're doing in this space and your partnership with TechSoft.
Great. Can everyone hear me and see my screen? Awesome. Thanks for the introduction, Jonathan. Hi, everyone. My name is Luli, and I'm a product manager here at Fieldwire. At Fieldwire, we're building productivity tools for specifically the construction field. So we're a field management platform that allows users to have all their plans, models, tasks, photos, everything that they need right in their pocket while they're on the job site. A little bit of background on me. Before I came to Fieldwire, I had a civil engineering background. That's what I went to school for. And I've been in the general contracting world ever since. Started out as a project engineer and then moved towards VDC and BIM coordination. That's what I did for the last 3 years before joining Fieldwire. And now I'm on the product team, creating new products and features that support field coordination teams. So a little bit about Fieldwire as a company. We have a global presence. We're on 750,000 projects over that worldwide. We started out in our San Francisco HQ. That's where I'm currently located. However, we do have growing offices in Phoenix, Arizona, as well as Paris, France. And we're seeing a little bit more of adoption in Australia as well. So yeah, we're growing pretty rapidly, and we're in over 100 countries, and we support up to 13 languages currently on our platform. And we're used across all types of projects. It's not just the mega billion-dollar airports, but what's great about our tool is that it's perfectly scalable to any type of job. So we do small T&Ms as well as your large airport or bridge constructions of the world. And yeah, we're basically a one-stop shop for the field. So we support plans, the 2D plans with automatic hyperlinking, making it really easy to view your plans on your phone, as well as do markups, photos, etc. But then we also support the plans with other contextual information, such as files like RFIs, submittals, forms like daily reports and inspection requests, and then tying it all to tasks. We have a robust task engine that can be that's flexible for any type of workflow, such as punch lists, snagging, QA, QC inspections, and etc. And the beauty of those is that they're like real-time alerts slash messages. So it's like similar to texting, but all of the context of what you're texting about is directly located on the plan or have the RFI attached and photos included as well. So then we also support 2D photos as well as 360 photos and videos as well. So our venture in supporting 3D formats is relatively new. It actually just launched earlier this year. So back when we were evaluating how we were going to support our customers' growing needs for needing that 3D information, as you guys know, more and more projects are starting to use BIM. So we wanted to support our customers doing that as well. So we had a couple of requirements from our users that helped us get into a partnership with TechSoft 3D. One of which was we needed something really high quality and polished, something that a superintendent could easily use, but and not give up right away, right? Because once you lose the confidence of a superintendent or somebody in the field, it's really hard to gain that. It's really hard to gain that back. We also had requirements that the BIM support needed to be on web and mobile. Specifically on mobile, we needed offline capabilities. A lot of our project sites, when they get started up, they don't have a Wi-Fi connection. There's no LTE or 3G in those areas when projects are just coming off the ground. So we wanted something with offline support, as well as, support for classic BIM formats. Some of the other 3D viewers out there or the other SDKs out there, they're really more for either manufacturing or 3D graphics for movies or 3D printing. We needed specific support for BIM formats. And then additional value adds that we got once we started working with TechSoft is really how easily customizable the UI and UX is. While the technology is really great, we wanted to build a little bit on top of that to make sure that navigation, viewing, ease of use, all of that kind of matched Fieldwire's current branding, and it was really part of our app rather than like a little off to the side. And then I was really impressed with the partnership and transparency that the guys over at TechSoft offered to us, working through issues and problems together. So all those requirements plus the additional value adds, it just made sense to go forward with this project. So a little bit about what type of tech we use. So currently our users are able to upload IFC files. We chose IFC files because of the flexibility of that file type. It's open source. So users upload that IFC file, which gets put into Exchange. Now with Exchange, we get all the metadata from those files, as well as 2 different files based on the platform that they're going to be used. So we get a PRC format that gets pushed to visualize. That's what our mobile applications use, so that they can have the offline as well as all the metadata that's from Exchange in the PRC format. And then we use SCS to push to HC Communicator for our web platforms, because it's a little bit more lightweight, but it also offers all that rich metadata. So the various use cases that we support currently with the tool are obviously visualization. You get that 360 view of the project with all those other model elements in context. That's the additional benefit of not just relying on 2D plans. But I think the biggest thing for users is access to that metadata. The things that are just not specifically called out in the plan, like further dimensions, like surface area, volume, etc., manufacturer's info, or like what type of material that you're dealing with. And for our MVP product, we also gave users the ability to access measurements that's, again, not available on 2D plans. You have the extra benefit of visualizing the z-coordinate, or in this case, the height. So with that, I'm gonna just show you guys what our application looks like. So when you're in a 3D project in Fieldwire, this is what you'll see. So I have a model open here. We have 2 different types of navigation modes because we want to support 2 different types of workflows. So for some users, like specifically manufacturing and stuff, you want to be able to rotate the model in sort of an orbit view when you're on the outside of things. But as you get inside the building for more commercial building, it's easier to navigate in a point of view mode, kind of like a video game, so that you get more of a 360 context of when you're actually inside the building, because rotate doesn't work as well as the point of view mode, which people are used to when they're walking their job site. So I've heard superintendents comparing this to like a digital job walk, which is like really exciting. So those are 2 different navigation modes. If you click on any model element, that's where you'll get all the metadata and properties that can come with an IFC model. So as you can see, we not only get just the IFC metadata, but we also get that the Revit metadata as well. And users really like being able to see everything that comes from the Revit model, but have that be accessible to them as well as out in the field. So that works the same. So I can tell that this wall is an interior partition that's 1 hour rated. You know, that information normally on 2D plans could be on separate plans. Like there would be a partition schedule, and then you'd have to kind of look at 2 pieces of information at once to get that full picture. But in this case, you can just click and see it. You can obviously control the visibility. We give users the ability to hide or isolate different model elements. And then we also give users the ability to measure points in the model. What I really like about this is that because we have all that BREF data, we're able to snap to edges and corners to get truly accurate measurements that might get lost in 2D plans sometimes. Anybody who's done an estimate will know that sometimes you just can't get it to exactly snap to the edge if you're not using tools like Revit or AutoCAD. And this way, this is accessible to them outside of those traditional environments. And then you get, you know, the entire, not only the full distance, but all the XYZ coordinates as well. And this is really useful, particularly for height, which again is not all those heights are available to you in sections on the 2D plan. And then we have the view cube on the right here, just for easy, quick navigation of the model for those who just want to get an outside view of it. So that's our web platform. I do have my iPhone connected, so I just want to give a quick peek on what it looks like on mobile. Really similar functionality, but instead, obviously, the navigation is more gestural. I'm like pinching and zooming and panning with my fingers. But this is the real value, having like the same model. You know, a lot of times 3D models, while they're being more and more used on construction sites, they're normally isolated to the trailer or the offices. It's not as accessible in the field. But now our customers have this in their back pocket, and they can just quickly reference things, you know, tap on model elements and get those same properties that they did on web. And this is just great for them, again, to make more informed decisions while they're out in the field, but also just a quick reference instead of having to ask the question and maybe escalating it to an RFI. This kind of answers all those things for them. And just a recap on the results, you know, we had pretty aggressive GTM goals. We started talking to TechSoft back in late fall, and our BIM viewer launched earlier this year, like I mentioned, January for our web, and then February, March followed for Android and iOS. So it's relatively recent partnership, but we've gotten a whole lot out of it. And initial user interaction and feedback has been really, really positive, actually. People are impressed with how polished our product looks, especially since this is our MVP, and they just want more and more features now on top of it. Some insight into some of the challenges ahead. One thing that's on the roadmap for this year is optimizing the mobile experience. And I showed what it looks like on the iPhone, but one of the considerations is, you know, our user base, again, we're primarily for the field. So our primary users like a superintendent and foreman, and sometimes they don't have the latest and greatest devices. So that's been a little bit of a challenge supporting 3D, because it is a very memory intensive process. So for those larger models on those big projects on older devices, it has been a challenge kind of getting those to open. So we're working on trying to optimize the mobile experience, and we're working with TechSoft on workarounds we can do in regards to that. And also further integration of BIM into our current app. You saw in my demo that, you know, the 3D models tab, it's a separate tab. And while it works great for what it is, users are really interested in you know, parallel workflows that they can have while using the 3D model and the 2D plan. So connecting those two, as well as maybe connecting tasks to plans so that they can track issues based on model parts and things like that. So those are the challenges ahead for us. We want to be able to fully integrate BIM and the 3D models into our current app. So that's all I had. If anyone has any questions, happy to answer them.
Thank you. That was fantastic. We always love to see what our partners are doing and the innovation you're bringing to the field. Do you feel like that's a differentiator for Fieldwire, being able to have 3D at your customers' fingertips?
Well, I think there's a couple of different competitors that also offer 3D capabilities. I think the real value add is having 3D as an additional context to all those things, like I mentioned, like robust task management. If you're, doing your punch list and want to quickly reference a 3D element, or on your plans, and the RFI doesn't paint a clear enough picture because you can't visualize all the MEPs stacked together, it's more of it's a value add because we support all those things across the platform. And I think that's what the differentiator is. Some competitors are solely focused on BIM, some competitors are solely focused on cloud sharing of documents, but we pride ourselves in supporting the full workflow of any field coordination need you may have.
Fantastic. Another question came in here. Do you anticipate supporting contextual information given the mobile devices? So I imagine, like, are you going to present your users with information if they're in this room or on this floor, kind of filter the data that's coming into them dependent on QR codes or GPS coordinates?
Gotcha. That's a great question. So currently we don't support that, but I can imagine a future way down the line. The technology is evolving constantly, right? I think the hard part of contextualized information is knowing exactly where you are with that. Like Gavin mentioned, with GPS coordinates and just placing of the model when it comes to AR or mixed reality technology. The placement of it is really great for Pokemon, not so easily transmittable to HVAC units. So I'd love to be able to do that. We are offering some GPS coordinate metadata when it comes to our photos. So as that technology evolves, it would be really interesting to see how we can bring 3D into the mix in the future.
That's great. Okay, a few other questions. Thank you so much. So either for Gavin or for Lee, if you just type them in their chat, we'll kind of go through those. Taking a look at what requirements for the computer, server, or local PC, which render whole digital factory with hundreds of machines. So good question. So we saw that demo with all of these machines. So that was being done on a laptop, but like a gaming laptop. So we're looking at an RTX 5000, I think was the graphics card. So like a decent machine, but it wasn't like a full workstation. And then there was a lot added on top of Hoops Communicator to kind of crunch all of that data down. So there's a simplification of all the meshes that made them very lightweight. All the machines kind of had this shrink wrap to it. And then if you wanted to drill down into it, you could load it on demand. And so because of the flexibility of the Communicator API, we're able to do that. If you wanted to load that entire factory with all the machines at the same time, it would bring even a workstation to its knees. But we can do some very interesting things using the API and using the data we have access to us. So, and then another question, your demo of Digital Twin Factory here today is great. Are those models with real size dimensions? How does the performance of the digital twin devices sync with real world synchronization with real worlds? So all the data we're working with was real data that came from different resources. So you looked at Luli's demonstration, that's real data. You're making real measurements on it. We can make real measurements on those machines as well. And all the unit data comes in using Hoops Exchange. So that is real data with real size dimensions. Some of them, like let's say the articulating arms, are just shells. Not all of them are fully modeled, but that is real data. But yeah, good questions. Anything else from people out there? All right. Well, we do appreciate everybody's participation today and just joining us for this virtual event. We have another one coming up 1 week, same time next week. We'll be talking more about manufacturing and what goes into the digital factory. I believe that Stratasys is going to be presenting as well as our partner presenter, talking about 3D printing and what they're doing in that space. Then if you're a developer, we also have some virtual training series continuing. So next week we'll be talking about taking our web technology, packaging it using component technology, particularly Docker, and distributing that and scaling up. So you'll learn a little bit more about how our SDKs kind of fit into that type of development paradigm. And then the following week, we'll be talking about data prep for 3D printing using MachineWorks Polygonica. It doesn't have to be just for 3D printing. In fact, in building construction, Polygonica is a really powerful way to simplify your mesh models. It's good for analysis as well, creating kind of unified meshes. So there's a lot of different use cases, but we will be kind of focusing on 3D printing there as well. So what do you do from here? We have a lot of content on our website. If you liked what you saw, please reach out to us by the contact us form on our website, or more importantly, evaluating our technology by going to techsoft3d.com, evaluate, and we can get your hands on these SDKs and couple you with one of our consulting engineers to create a proof of concept, work through any technical problems or questions you may have, and how to best utilize our SDKs to build really compelling applications like Fieldwire has done. Check out their stuff at fieldwire.com, a really interesting new work they're doing using our toolkits as well. Sanna, SANNA.io, and their BIM connector. Some great stuff there. We're really excited to be partnering with them. So if there's no other questions, we appreciate your time today. We look forward to seeing you in person at some point. But for right now in the virtual world, we'll have to make do. But thank you, everyone. Have a good afternoon or the rest of your morning. Take care, everyone.
All right.